Alright, I've lowered the quality of the stream. Should be easier to see now, right? Right, I know I can't stream at that bitrate anymore now. That's no worries. Hopefully you guys can still see the code okay. Right, let's carry on. Sorry about that delay. So what we're going to do then, inside here, we create the kernel packet and we send it. Now, I'm going to output down here that it was sent. If we see this, and we are still waiting a few seconds, we know that there's a problem on the kernel side. Okay, so we see send, and it gets it, good. Alright, so the delay's on the client, which is good to know. So what's happening is somewhere on the client is a bit of a delay. So that could be because of our mutex. We're going to comment that out in a minute, which is a bad idea. But I think that's the problem. Yeah. Okay guys, we have a problem on the client side. No big deal. Basically someone's hogging all the resources. So that's why there's a huge delay. Not a problem though, we can solve this, don't worry. So send packet here, we have a lock, a packet lock. Where else do we have it? Because one of these guys is slowing us down. So send packet, receive packet, find socket. Which one's hogging this? Okay, send packet, send ping packet, that's fine. Send create ID response packet. We have a while loop here that sleeps 50 milliseconds. Receive packet. That locks it. Alright, what I'm going to do here, I'm going to comment this out a minute. So I really need to find out what's causing this, right? We're going to go send create ID response packet. Packet.semid. We're just going to see if that is faster. Yes, it's far, far, far better. So I know what's slowing it down. It's receive packet, guys. There's a 5-second timeout. So it's holding our lock for a full 5 seconds, which is why we have a problem. Basically. Ah, shit, that's the problem, isn't it? That's a problem and a half. Bollocks. Oh, God. How do we get around that then? We can either have the kernel send ping packet at regular intervals. Alternatively, we might be able to remove the lock altogether if we put a lot of the logic in the local functions and not rely on things that are in the class header. I think we need to do that. Guys. I think that would make a lot more sense. We're gonna do that. This should be safe. Should be. Should be okay. I don't think the destination address has changed. I think it'll be fine to do this, guys. I don't see a danger here, right? Alright, so we can get rid of the lock then. Alright, that should do it. We are creating new memory every time we want to send a packet, which isn't ideal. I think we can do it on the stack here, guys, to be honest. Oh, no, we can't. Okay. Alright, I know what to do then. We need to change this. Oh, I can't. Shit. Yeah, this is a problem. It's a problem. Yeah, we can do this on the stack, I think. Yeah, let's do this on the stack. We'll be fine, right? Should be alright, I think. I think this is gonna be alright. That'll work, guys. That should work fine. Can that be cleaned a little bit more? I don't think so. Alright, cool. This should speed up everything. Alright, you see it's shit like this where we need a lock. Right? It's not good. It's okay though. It's okay because I can remove that for that functionality. It's fine. We can have a fixed timeout. I don't have to worry about any lock or anything then. Because we're working on speeding this up, right? Because my mutex was caught in that 5-second loop, causing delay, a 5-second delay for all packets. Ridiculous. We can't do that. So I just got a 5 here for now. We'll change it to definition later. Alright, I think this will work now because I've switched everything to use the stack. DMP kernel pack is quite large, I think. So hopefully that's okay. I don't want to create heap memory every time we receive packet. It's too it's a heavy operation. Oh, we won't have the config there. We'll just do it here, cleaner. Okay, fine, that's good. Alright, nice. And now we can actually test if this works. The hell is going on? It's crashing. Bollocks. Alright, let's find out why. Why are we crashing? We fail in the thread pool, do we? What happens in the thread pool? We don't join. That was clever. It's no wonder we're having so many problems. Right, yeah, we need to join. That was a stupid mistake. Alright, that should fix that one. There we go. Looking good. Now we sent our test packet and nothing happened. I think what's happening, I think we are we leaving scope? It can't be, there's a while loop there. We start the kernel client. That starts, sends ping packet and whatnot. Receive ping packet. What does that do? Does that work? So we come in here, receive packet, and then Oh, wait a minute. I'm not mem setting this, guys. Could that be why? Let's check for that. I know this code's looking a bit bad right now. I'll come and clean this. I mean, it could be why, right? Shit, I messed up. I messed up big time. I forgot to use down timeout. I used down, which means I've actually totaled one of my CPU cores right now. That's why we can't remove the module. Basically, I'm stuck in my kernel module. One of my cores is jammed. Look, I'll show you. See this down here? It is waiting and waiting and waiting and waiting for a response, which it's never going to get. So I've basically lost one of my cores there. As a matter of fact, I ran that 4 times. The machine would probably halt. I've only got quad core, right? Let's try that. Let's try and change this to timeout. God's sake. That was such a stupid thing to do. Can't believe I did that. 30 seconds. And that would fix that. But this is really annoying now because I can't actually remove it, which is a problem. Alright. Oh no! Did I panic? Oh, there we are. The kernel caught it. Nice. Blocked for more than 120 seconds. But does it then? Oh shit! It doesn't let me remove it after that. Bollocks. Alright, well that was a stupid mistake, right? I knew exactly what I did the second that error happened. The second it happened, I knew exactly what was wrong. I just fixed it, but I can't actually insert the module again because it's stuck. It is stuck, and you know, that means that I can't actually continue without rebooting my computer. But I'm not going to do that tonight because it's late, so I'll probably call it here then, I guess. There's nothing more I can do without a reboot. Literally the module is just jammed in there. Yeah, one thing about Linux is when something goes wrong, there's no blue screen of death like in Windows. It actually displays it displays a trace and lets you continue to use the machine, which is quite strange, to be honest. I mean, how is that even safe? But maybe for more serious things, then I mean, like, I know I've broken the kernel so bad before that the whole machine's froze, and you know, the off button wasn't even responding. I had to hold it down until it killed the system. I corrupted the entire file system doing that as well. Yeah, this is annoying. At least it caught that I was stuck in a loop. That's pretty impressive, right? It actually caught that I was stuck here, and it resolved it, which is pretty impressive if you ask me. But I have to call it here because I have to actually reboot to continue, and it's 11 o'clock now. I was going to call it in 10 minutes anyway. So yeah, nothing I can do here. But this is fine. This is great because I've actually figured out why the packets were being transferred very slowly, and the reason it was transferred slowly is because my mutex for thread safety was basically, there was a timeout on the socket, So I waited 5 seconds before saying, oh, they have no packets for us, let's carry on. Waited 5 seconds before telling me that. So it would hold the lock for 5 seconds, meaning we couldn't send packets. So what I'm doing now, I'm taking a lot of the global functionality and putting it in the local function, so I don't need to use a lock, right? And it should work fine for me because I find I send packets in fixed lengths. Like it's not like TCP where there's like, you know, you're gonna send a gig or a meg. These are fixed length packets that are being sent, like UDP, right? Obviously in the future, if I decided to go down the streaming route, then it may be a bit more complicated to get right. But I'll cross that road when I get to it. When I get to that road, I'll probably just implement my own version of TCP just so I don't have to change this functionality. To be honest with you, I could use TCP, but then it would mean changing this functionality, and I'd rather not do that because I've already put a lot of work into this. So my own TCP implementation purely for DMP would work fine for that. And it should work fine because we would split it up into DMP packets and send those one at a time. Yeah, it would work. Should work, maybe. Apart from when we're waiting for responses, because when I wait for responses, I wait on a semaphore, right? And the kernel, I'll show this now. The kernel. Inside my kernel module, you see, where is it now? Where is it? DMP kernel server, here we are, cool. So what happens is, I'll tell you how this works. It's a pretty cool thing, right? Basically, firstly the problem. The problem is, I can't just, when I send a command to the kernel server, which is a server I have, it's a user program, and I send a command from the kernel to that, I expect a response. Now what if they reply with a ping packet or something unrelated because they just happen to send that to the stack, to the kernel side, through the network protocol, netlink. Well, then I received the wrong packet. So then yeah, I could just ignore it, but then someone was expecting that packet, right? So that was a stupid idea. So what I do to solve that, maybe a bad way, maybe good, I don't know. I think it's okay. I have what I call send and waits. Send and waits contain a semaphore. They contain the packet, and bool taken means has this send and wait already been taken. So I have 30 of these currently, and what happens is when someone wants to, like, look at this, create address for example, we go DMP kernel server send and wait. We pass in the packet we want to send, and then we pass in a response packet. The response packet will be filled with the response that we get back from the user program, because we don't do things like file management in the kernel. That'd be crazy, right? So we send it to the user program and let that deal with it, and then it sends the command, it sends the response back to us and stuff like that. So I haven't seen them. DMP kernel server